Imagine looking at a spiral galaxy in deep space. It looks completely serene, right? Perfectly balanced by the laws of physics we all know and love. And for a long, long time, humanity just assumed that what we saw through our telescopes was the whole picture. But there's a problem. Beneath that stunning cosmic display, there is a massive gravitational anomaly hiding right in plain sight. In this explainer, we're exploring one of the absolute most profound mysteries in astrophysics. Because when we look up at the night sky, our instruments and our eyes are literally only catching a tiny, tiny fraction of the actual story. Here's the absolute shocker. Every single blazing star, every swirling planet, every massive cloud of glowing interstellar gas, basically all the normal matter we can actually measure, makes up less than 5% of what's actually holding that structure together. It's wild to think about. All the complex chemistry, the black holes, the radiation, everything that makes up our known, tangible universe, it's essentially just a rounding error in the grand cosmic ledger. That means 95% of that galaxy, and essentially our entire universe, is completely invisible to our instruments. Take a second to just let the sheer scale of that missing universe sink in. So when we break down the composition of our universe under the standard cosmological model, that little 5% slice, that's normal matter. Atoms, stars, you, and me. The 27% slice is our main suspect today, dark matter. It doesn't emit, reflect, or absorb light, but gravitationally, it is very, very real. And that massive 68% chunk, that's dark energy, the mysterious force that's actively accelerating the expansion of the universe. We'll actually save that specific mystery for another explainer. Right now, our focus is entirely on that unseen 27%. Okay, let's dive into this. Because, you don't just wake up one day and realize a quarter of the universe is missing. It took decades of really frustrating, mind-bending observations by some incredibly persistent cosmic detectives to uncover this anomaly and to force the scientific community to accept that our models of reality were fundamentally incomplete. Back in 1933, Swiss astronomer Fritz Zwicky was studying the Gamma cluster, this massive group of hundreds of galaxies. He measured how fast they were moving and realized the math was just wildly off. Based purely on the mass we could see, that cluster should have violently flown apart eons ago. He deduced that some invisible matter was holding it all together. Now, Zwicky was brilliantly perceptive, but he was also famously abrasive. He occasionally called his colleagues spherical bastards, meaning they were bastards no matter which way you looked at them. So, yeah, maybe it's no surprise the scientific community largely ignored his dark matter theory for decades. It actually wasn't until the 1970s that astronomer Vera Rubin fully revived the case by mapping stellar orbits. Now, basic physics tells us that the further a star is from the dense galactic center, the slower it should orbit. That's exactly how our own solar system works. Neptune moves way slower than Mercury. But what Rubin found was that the actual rotation curve completely defied this expectation. The outer stars were whipping around just as fast as the inner ones. The velocity curve just stays completely flat. It absolutely refuses to drop off.
So why does this matter? Well, a flat rotation curve literally breaks everything we know about gravity, unless there is an absolutely massive, invisible halo of matter surrounding the galaxy. And we aren't talking about some flat disk of invisible stuff. This is a massive spherical envelope extending far, far beyond the luminous edges of the galaxy we can actually see. It provides the tremendous extra gravitational glue needed to keep those speeding outer stars from just flying right off into deep space.
We know it's there, for sure, because we can definitively measure its gravitational footprint. But the ultimate question remains, so what is dark matter? Particle physicists have spent decades trying to trap it, mathematically define it, model it. And while the answer is still incredibly elusive, the scientific community has narrowed the field down to three main suspects. Suspect number one, WIMPs. That stands for weakly interacting massive particles. Think of a WIMP kind of like a heavy cosmic ghost. It has mass, meaning it exerts gravity, but it doesn't interact with electromagnetism. It only interacts via gravity and the weak nuclear force. That means it can pass straight through solid matter completely undetected. For a long time, WIMPs were the absolute favorite child of physics. But here's the catch. Despite building massive underground liquid xenon detectors to catch them, we haven't confirmed a single one, which naturally only deepens the mystery. Suspect number two points to axions. These were originally proposed to solve a totally different puzzle in quantum mechanics, but physicists soon realized these theoretical particles could beautifully explain dark matter too. If a WIMP is a heavy ghost, an axion is more like incredibly lightweight cosmic dust, literally billions of times lighter than a single electron. Individually, they do almost nothing, But if they exist in massive, cold fields drifting through space, their collective gravity could easily account for all that missing mass. Suspect number 3 is a bit more dramatic: primordial black holes. Now, we aren't talking about your standard black holes born from dying stars. These are ancient, incredibly dense pockets of mass that collapsed in the chaotic, high-energy fractions of a second immediately following the Big Bang. The theory actually fell out of fashion for a while, but recent gravitational wave detections for merging black holes have scientists wondering, what if the dark matter we've been looking for has simply been locked away in these ancient, invisible sinkholes since the dawn of time? But dark matter's influence isn't limited to just holding individual galaxies together. When you zoom way out to observe the large-scale structure of the cosmos, dark matter acts as the enormous, invisible skeleton of the entire universe. It forms what we call the cosmic web, vast, sprawling filaments of dark matter stretching out across hundreds of millions of light years, intersecting at these massive gravitational nodes. And this brilliantly illustrates just how accurate our models really are. When we look at massive supercomputer runs like the Millennium simulation, they map out where dark matter should naturally clump together over billions of years. When we compare that simulated framework against the actual observed map of the universe, the alignment is absolutely breathtaking. The visible galaxies flawlessly trace the invisible dark matter scaffolding, proving that our theories about its structural role are right on the money. Galaxies simply don't form randomly out in the void. Normal matter, the raw gas and dust required to eventually ignite into stars, is inexorably drawn into the deep gravitational potential wells created by the dark matter web. Without those invisible dark matter nodes acting as the ultimate cosmic anchors, gas would never have clumped together densely enough to form stars in the first place. There would be no galaxies, no planets. We are, quite literally, the glowing children of something we cannot see. Which brings us to an obvious logistical problem. How do you physically map an invisible web? Well, you look for the shadows it casts. It's exactly like knowing an invisible person is standing right in front of you on a sunny day, purely because you can see their shadow blocking the light on the pavement. In astrophysics, this shadow play relies on a mind-bending phenomenon predicted by Albert Einstein, called gravitational lensing. According to general relativity, massive objects physically warp the actual fabric of space-time. So when a massive cluster of invisible dark matter sits directly between us and a distant background galaxy, its intense gravity acts like a colossal magnifying glass. As the light from that distant galaxy travels toward Earth, it's forced to follow the curved path of bent space. The light stretches, distorts, and often forms a perfect luminous halo known as an Einstein ring. We can't see the dark matter itself, but we can literally watch it bend the light of the universe around it. So what does all of this vast, abstract physics mean for you, sitting right there? Well, because this massive dark matter halo permeates our entire galaxy, including our very own solar system, it means that right now, hundreds of thousands of dark matter particles are passing through every square inch of your body. Every single second. You never feel a thing, and they never interact with your atoms, but a silent, invisible storm is washing through you constantly. It is the absolute most vital, mysterious substance in existence. It built the large-scale structure of the universe. It shaped exactly where our sun would be born. And yet, almost a century after Fritz Zwicky first noticed something was mathematically off, we are still swimming in an invisible ocean, just waiting to finally see the water. With next-generation detectors and telescopes coming online this decade, the ultimate question is, will we be the generation to finally pull back the curtain? Or will dark matter remain the universe's?
If you want to keep exploring the deepest mysteries of space, subscribe to this channel because we're just getting started. Drop a comment below. Do you think we'll ever fully solve the great Attractor mystery? I'll see you in the next one.